So what is this starting to look like? This is what? This is 1500, right? Plus 50x plus 30x plus x squared. This now becomes x squared plus 80x plus 1500 equals 3000. That is not the way you want a quadratic equation to look, because you want it to be equal to 0. So I must move the 3000 to the other side. This becomes x squared plus 80x minus 1500 equals 0. Do you see that? How many of you ever thought about widening the building to twice its size involves a quadratic equation?
Just figure they want more space.
Somebody has to do the math. Somebody has to solve that equation for x. That would be an easy one to do what with? Complete the square. Why?
Because it's an even number on that first.
The 80 is an even number. You can pretty easily do that. But you can also do what? X is equal minus b plus or minus the square root b squared.
I got that. I get it.
This is approximately equal to. You add about 15.6 feet to the length and the width, you double the size of the building. Easy enough? About 15.6?
So you add 15.6 to both, to the 50 and...
Length and the width, and you double the size of the building. Listen up. If you could do this, if you could tie a string around the earth, around the equator, if you could tie a string around the earth at the equator, I need a ballpark figure, okay? Because you're not going to be able to calculate it precisely, whatever. I want you to do that same string around the earth, but I wanted the string to be 3 feet off the ground all the way around. Does that make sense? I don't want it to be touching the earth. I want it to be what? 3 feet out. How many feet of string extra would you have to add approximately to your string?
3 feet?
The diameter plus 6.
I know
The
the
diameter
equator.
plus 6. Oh, no, never mind.
Oh, no, I don't think.
Give me a ballpark figure, somebody.
For the equator, 40,000 is how long the equator is. Kilometers.
That's like 26,000 miles or something.
That's how long the equator is, which is 24.
What do you think it'd have to be? Somebody make a guess.
150,000 miles.
For what?
150,000 miles.
Feet or miles?
Miles.
Add that to the string, and then it'll go out 3 feet out.
I mean,
Anybody
without
else?
it being off the ground, it's like 24,000.
What now?
So without it being off the ground, it's like 24,000 miles. So with it being
25,000 miles.
You just, if it's going 3 feet up, aren't you?
25,000 miles around it.
yeah.
No, I was thinking altogether, it's probably, it's not 50,000 miles.
So about how many feet? I mean, how many miles?
50,000 miles?
Add that much to the string.
Why would you add if you're just making it 3 feet high? Why don't you just lift the string
Because the
up?
whole circumference of the earth is gonna be that much longer.
Now, would you believe you're gonna put this string around the earth now, around the equator, and in every single place, it's gonna be 3 feet off the ground, or off the ocean, or whatever. Enough for you to crawl under it, okay? Any place you want to, you can crawl under it. Probably, to make that happen, less than 12 feet. Look at it going, huh?
You see what
I never thought about that.
You're just lifting it up.
But yeah, it's an incredibly small amount that you have to add. Look at Doubting Thomas back there.
Look at it.
Doubting Thomas over here. Doubting. Wow.
His name was Thomas.
It's a very small amount, believe it or not, that you have to add to make it 3 feet off the ground all the way around the earth. I think to make it like 6 inches off the earth is something like 3 or 4 feet. Less than 6 feet of string, I remember. I don't remember exactly the number, but. It's time to go. Y'all run me overtime.
We were waiting on you. We just did it once.
Don't you?